on your notes, I don't think. But I recommend pausing this and just seeing if you could identify these because this will be tested and it's pretty important. So if you aren't sure of these names, like what they mean, that might be a problem because a secant and a tangent are both lines or rays, but if it's a segment, it's probably a chord or a radius or maybe a diameter. So it's kind of important that you understand the difference. So this first one is segment BE. So it starts at E and stops at B. Those are both on the circle. So if it has its endpoints on the circle, it is a chord. However, that one goes through the center of the circle, so it's actually a diameter, which by definition, a diameter is a chord. Line BD goes through the circle 2 times, so that is a secant. I don't know why this isn't working. All right, point A, if it's just a letter, it's a point. Point A is where this tangent line hits this circle, so that is a point of tangency. Sorry. All right, segment AC is a radius. Segment BD is a chord. The difference in this one and this one, is that it's a line versus a segment. And then line AG is a tangent. It's actually tangent to both circles because it touches each circle at one point. All right. So we've already done the middle part of these notes. And so now we're going to do the last column. And we've actually already done this part where you do Pythagorean theorem. So luckily there's only 2 different things we have to know. If it's inside the circle, doesn't matter if it's in the center or not, we are doing part times part equals part times part. If it's outside the circle, we do outside part times whole thing equals outside part times whole thing. So the way that I know that it's segment length and not the middle column, which is arcs and angles, is because arcs and angles are in degrees and these are not going to be in degrees. Okay, so these 2 lines intersect inside the circle, which is part times part equals part times part. So let's focus on just this segment, and you don't have this on the notes, so just look at it. This is one segment. So this part and this part, we multiply together. Part times part equals, and then we do the other segment. Let's change colors. It should equal this segment's parts multiplied together. So DE times EC. So it's this part times this part equals this part times this part. And I'm just marking them. Those aren't congruent marks. But that's what the part times part means. This is the one we've already done where it's on the circle and we did Pythagorean theorem. So we did like AB squared plus BC squared equals AC squared. That's just Pythagorean theorem. And then outside the circle is when you do outside part times whole thing. And this one's a little bit more confusing because it's not just part times part. So let's start with this one. The outside part is EA. And we multiply that times the whole thing, which is EB. A lot of people want to do part times part there, but you have to do just the part on the outside times the whole thing. And that should equal the other segment, which is EC for the outside part, and the whole thing is ED. Now the reason I have 2 pictures here is because sometimes one of them is a tangent, not a secant. So the outside part and the whole thing are the same thing. So there you would just do EA times EA or EA squared, and then outside part times whole thing, which is ED. This only happens right here if, if the outside part is the whole thing. So you're still doing outside part times whole thing, but you end up with the same thing on that one. All right, so this is inside the circle. They're not degrees, so we know it's not arcs and angles. So we do part times part. So let's see, this segment right here, part times part is going to be 8 times 6. And that's going to equal this one's part times part, which is going to be 12 times x. So we get 48 equals 12x. And if you divide both sides by 12, you get x equals 4. Okay. Now for this one, the math and algebra might get a little harder. So part times part equals part times part. You might want to look that over and see if you understand how we got that. So 7 times 2x is 14x. Now remember, when you have a number times a binomial, you have to distribute it. So we get 12x plus 6 times 2 is 12. So I'd subtract the 12x, get 2x equals 12, and divide both sides by 2 and get x equals 6. So let's just check that to make sure. So if x equals 6, then 2x would be 12, and 12, 13, 14. So is 7 times 12 the same as 6 times 14? 12 times 7 is 84, and 6 times 14 is 84. Perfect. Okay, now this one is a little bit trickier. It's still part times part, but you're going to have to use FOIL or double distribution, which is not difficult. I think you can do it. So we have x plus 1 times x plus 5. Those are the two parts on segment CD. And the other two parts are x plus 2 and x plus 3. So double distribute means you distribute the x to each one of these, and then this number to each one of these. So x times x is x squared. That woke up my echo. Never mind, echo. X times 5 is 5x. 1 times x is 1x, and 1 times 5 is 5. Then we can combine our like terms and get x squared plus 6x plus 5. And I know it seems like a lot of work, but you'll get used to it because it's not bad. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. So I get x squared plus 5x plus 6 on that side. So then I'm going to subtract my x squareds, and then I'll subtract my 5x. So I'm just left with x plus 5 here, and 6 is here. Then subtract my 5, and x equals 1. Now, that's not what we were supposed to find. We're supposed to find AB. So if x is 1, we get 1 plus 2 is 3. 1 plus 3 is 4. And AB equals 7. Let's see if I hid the answer under here. Yeah, it's 7. Okay. Now we have outside the circle where the two lines are intersecting, which means we do outside part. I'm going to write this down. Times whole thing. And it equals outside part times whole thing. I'm not going to write it twice because I don't have room. So let's start with this top line. The outside part right here is 6. And the whole thing is, be careful, because it's not x. The whole thing is this x plus this 6. So I'm going to call it x plus 6. And that equals the outside part of the bottom line, which is 7. And then the whole thing, which is 7 plus 5, so that's 12. So don't forget to distribute. 6x plus 36 equals 84. Subtract the 36 from both sides. You get 48. So we have 6x equals 48. So x equals, when we divide, you get 8. Sorry about the little tail on my x there. All right, this one is only different because the outside part and the whole thing are the same. So outside part is 12, whole thing is 12. Then outside part is 9, whole thing is x plus 9. So we get 144 on this side, 9x plus 81, because I got to distribute that to both of them. So 144 subtract 81, that's 63. So we're left with 63 equals 9x. I'll go ahead and write this for anybody who needs to see it. So x equals 7. All right. Outside part times whole thing. And you can always pause these and try them if you want. Sorry, I'm just looking through what's left. So outside part on the top line is 9. Whole thing, we add these together. 2x plus 10. Because if I do 2x plus 1 plus 9, I can combine the 1 and the 9 to get 10. And that equals the outside part of the bottom, which is 10, times the whole thing, which is x plus 13, because I add x plus 3 plus 10. So I distribute and I get 18x plus 90 equals 10x plus 130. So I'm going to start by subtracting my 10x, get 8x plus 90, equals 130. Subtract my 90 and get 40 equals 8x, and then divide both sides by 8 and get x equals 5. Not too bad. And I'm not sure what's going on with this. That goes there. So it's outside part. I'm going to do the bottom one first. I don't know why. Outside part is 36. Whole thing is also 36. And then outside part on top times the whole thing, which is 24 plus x. So 36 times 36 is 1296. 24 times 24, I'm pretty sure is 576. Let me check that. 24. Yeah. And then plus 24x, because you got to distribute. So I'm going to subtract the 576 from this side and this side. 1296 minus 576. Get 720 equals 24x. Divide both sides by 24 and you get 30 for x. And it asks for PQ, but since x is 30 and PQ is x, we'll just say PQ is 30. All right, now this is the last one. Of course, it's the most difficult because you do have to FOIL. So it's going to be outside part times whole thing. So think about what you would put for the whole thing, because you got to add these together. Most people forget to do that. So if I say x and x, I get 2x if I add them. 1 and 3 make 4. Then the other side, the outside part's x plus 2, and the whole thing is x plus 4. So let me FOIL this, just like this. I'm not going to write the arrows on this one. I'd really like for you to pause it and see if you can do that on your own. Nope, 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 nope. Can I do it on my own is the question. Okay, so 2x squared plus 4x plus 2x plus 4. That's what I get when I FOIL this side. Now I'm going to run out of room, darn. Okay, so we have x squared plus 4x plus 2x plus 8 when I FOIL this side. So 2x squared plus 6x plus 4 equals x squared plus 6x plus 8. So I'm going to subtract my x squared, but this time it doesn't cancel out. However, if I subtract my 6x, it does cancel out. So 2x squared minus x squared leaves you with 1x squared, or just x squared, plus 4 equals 8. If I subtract my 4, I get x squared equals 4. Take the square root of both sides, so x equals 2. And in geometry, we always take the positive of the square root. In algebra, sometimes you do plus or minus, and you'll definitely do that in algebra too. But in geometry, since we're dealing with lengths of segments, we just take the positive. So if x equals 2, then what would e be? Have to measure. Let's see. 2 plus 1 is 3. 2 plus 3 is 5. So EB would be, sorry.